Welcome to My Academic Planning System, or MAPS for short. The goal of this project was to create a comprehensive course planning platform. Before doing any planning, it's important for a person to know where they're at, and so we have an academic status feature. Our program also boasts sophisticated searching platforms, where students can explore the concentrations and courses offered at the university. Last but not least, our program provides platforms for students to plan their courses for the upcoming semester and to create a 4-year plan. Should a student decide that they want to switch their concentration, we have incorporated a concentration request form. This demo will follow the journey of our student, Melech Achashverosh, with RUID ACH127 as he journeys through our program and explores the different features that we provide.
This is the presentation of the two login use cases, successful authentication and failed authentication. So for the first use case, successful authentication, we have some mock ID token. This would be something for real when we integrate the Google API, but for the sake of this demo, we will only be simulating it. And then we have our example net ID ACH127. And as both of these things exist in the system, you will see that it is a verified true identity and thus authorized to access the website as a Rutgers user. In this second example, the second use case, you will notice that there is an incorrect ID token and or this net ID that does not exist, HCA721, for example, and if they attempt to get themselves authorized, you'll notice that they are verified false because either their token or net ID is invalid.
Hello and welcome to the concentration search portion of the video. My name is Mark Schmidt and I will be reviewing the work that I've done on this. This has been completely done by myself. So to start, it's all based around the csearch.html file. I have some styling just to make things a little cleaner. But effectively, what happens here is I have a module script which does a fetch command to our Firebase database, which then essentially takes the query that is searched upon clicking the search button and essentially determines if there are any concentrations that match that search query either completely or some portion of it. So, and then what ends up happening is they get displayed as hyperlinks because when the idea is in the end that when you click on it, it will take you to another page that displays displays your progress and all the criteria required for a particular concentration. And in the end, you'll also be able to filter based on certain criteria between concentrations. So let me quickly demo that for you. So if we type COM, for example, computer science and electrical and computer engineering pop up. If I do TRD, that doesn't produce anything. If I do eco or econ, it'll pop up. And of course, computer science will only pop up on its own. So that's essentially how concentration search works so far.
Section of this video. I'm Sohom, and I will give you an explanation into our courses within our database and the web page with which we can interact with it. Now, each course is structured a certain way. It must have a name, description, credits, prereqs and coreqs, which are both references to other courses within the database, and sections, which is an array of references to all of the different sections that course has. Now, there's a few different operations we can do within the database, such as get course, which retrieves the information of the relevant course, insert course, which will insert a course into our database, update course, which updates the specified course with new information, and delete course. Here are a few different batch operations so that we can do the aforementioned methods en masse. And down here, we'll simply test one of our functions, get course. So here's a few well-known courses such as linear algebra, data structures, and discrete 2. And if we run it, we can see that we successfully get all of these from our database. Note that some courses will reference a prereq like this here, But if there's no prereqs, it will simply be left as null. Now over here, we can get a better look at the web page that will be used on the client side. Our client will pass in a search query, which will be passed in and used to filter the course in the course catalog to find all of the courses related to what the user wants. Over here, we can have a little demo. So let's say we want to find all of our linear algebra courses. We type that in, and we get all of the courses that are related to linear algebra. If we wanted to see all of our intro courses, we could simply do this, and we would get all of the introductory classes out there. And of course, if we type nothing, or some random letters in, we're going to see no courses found because there's no courses in the database that match this. And that's all.
Hello, my name is Rejaul Karim, and I'll be going over the critical aspect of our project, the concentration request system. This system streamlines the process for students to declare or change their academic concentration and helps administrators efficiently handle these requests. The two functions we will take a look at is create concentration request and fetch concentration request. Basically, what the concentration request function is, it captures a student request to declare or change their concentration, which is the name, net ID, and graduation year, and desired concentration from the request data. And for the fetch concentration request data is that it is vital for admins to oversee all concentration requests. Basically, what it does is that it retrieves all documents from the concentration request collection, mapping over them to transform file sorted documents into JavaScript objects. A use case scenario would be where a student uses our system to submit a request for concentration change. This request triggers the create concentration request function, efficiently logging the details and desired concentration into our database. In conclusion, the concentration request functionality embodies a perfect blend of front-end interactivity and back-end efficiency. Through just a couple of functions, we managed to establish a robust system for handling one of the most critical aspects of the project.
Hello, welcome to the academic status section of the video. My name is Aditya Rajesh, and I worked alongside Daniel, Aladeniyi, and Beshoy, Yacoub. So what is the academic status of a student? Well, it essentially is just a progress report for them. So it takes into account their GPA, their completed courses, their enrolled courses, their currently enrolled courses, and their future courses based off of what they've put onto their plan. So yeah, let's walk through the code here a little bit. So essentially, we first enter the program, and we create a controller. This controller then obtains the student's information by calling the student class. The student class pulls this information using the help of a few other classes from our Firestore database. Once we obtain the information of the student, which is currently the GPA, the completed courses, the enrolled courses, and the future courses, we then generate a report for the student. And additionally, we verify if the student is on academic probation or warning status, if you call it. This is essentially when the student's GPA is below 2.0. So if the student's GPA is below 2.0, then it pops up a warning telling the student that they're on academic warning because their GPA is too low. If they're fine and their GPA is sitting nicely, then the student will simply get a message saying they're in good academic standing. So after we do all of this, we then format the summary because this is the important part. The student, we need to be able to give the student a proper summary that's concise and allows them to easily see all of their progress at the university and all the things they need to do in order to completely graduate from the university. So we present them their GPA, if they're on warning status or not, and they're currently taking courses, their completed courses, and their future courses. And to show you what this looks like, we can use Postman here. So we have the student's net ID, and if we run it, you can see it's sending the request, and then we get the summary. So we have the student's GPA, which in this case is 3.9. The student, because they have a 3.9 GPA, is in good academic standing. Their currently only completed course is this course. They're not currently enrolled in any courses, given the information in our database, and they have planned they have added all of these courses to their upcoming semester plans. So in addition to the student being able to access their own academic summary, we actually have it so that another use case, our second use case, is for the administrator to access the student summary. This is only going to be a very brief topic just because it's very conceptually similar to the first use case, but I thought it would be good to touch upon. So instead of just letting the NET ID be the only thing we input, we also ask for the administrator's NET ID, just so that we can validate if they're an administrator or not, and if they aren't, we deny them access, but if they are, then we just give them the same academic summary as the student would get. An input for the admin version, the admin use case of the academic summary. So we instead of just having our student here, we also have the admins here as well. So we can try it right now. And it gives the academic summary, the same one, because we're also inputting the same student NET ID as well.
Hello, my name is Tom Simon, and I want to be explaining how we made a code to be able to allow the user to create a plan for the upcoming semester. So we start off by establishing some functions that are going to help us to, create the plan that we need. So we start off with the three functions that are going to help us with the Firebase and the helper function and the course function. So we established a class function to group all the functions that are going to be needed to help plan for the upcoming semester. So we have a constructor to be able to derive from the database to collect the information we need to help us help the user do the planning. So the first function starts with getting the information for our future course. So we try to return the information we need with the elements, which include the ID of our course, the name of the course, the amount of credits that will be taken with the course, and the semester the course is being taken. This leads to the next part of adding the course to the schedule. So these are what the user will need with the parameters of NET ID, the course ID that they received, and the semester that they're planning for. And they, in the try function, they try to input the course information to the upcoming semester that they're planning for. And we test to see that if it had worked out, and it will give two options would be if it has been added successfully, or if there was an error when trying to add the course to the schedule. So this goes to our next function, which is saving the schedule, which we need the same parameters as usual, and we allow the user to try to save the schedule that they planned for, and we see that it's either going to give us that the schedule has been saved successfully, or there was an error when trying to save the schedule, which leads to our next function where if the user wants to view the schedule, they would just need their NET ID and the semester that they're looking at, and we allow them the option to view the schedule, and it returns to see. And after they press the option, they either have the chance to be able to view the schedule, or they would get a message saying that the schedule has not been found. And to make it easier to be able to, create the schedule, we make sure that we filter the schedule, like the course information and all, by the concentration that the user is part of. And we have the handler function to handle any errors that comes by. So then we have like an example that, to make sure that the system knows like the type of information that will be needed to input the code, like the net ID, the course ID that they will get, the semester they're planning for, and then the concentration of the user. And this allows us to, allows the user to have the options to, um, find and add the course to the schedule, save the schedule, and be able to view the schedule. And that's that.
So now a student has access to his 4-year plan. He can perform various different things, and we're going to go through different use cases and the general flow of what a user can do. So first, a user can come and he can view his plan. He can see what courses he's taking, what semesters. We have 0 to 7 corresponding with the different semesters, 0 being freshman winter. Once he has his things, he wants to validate it. He wants to see, is this valid based on a concentration? So we're going to send the request, and we're going to see, no, our prereqs aren't valid. It's false, because we see that 135 prereq doesn't have 133, 134 doesn't have 133, 122 doesn't have 133, 121 doesn't have 111, 112, 331, because according to the business rules, a prereq must be in a previous semester, and we see that there are multiple situations in which this is not good. Co-reqs is the same thing. The business rule states that they have to be in the same semester, and we see that 125 and 121 are correct, and they are not being satisfied. Now, according to the concentration that this student sent, he wants to validate psychology 03267 to see, did he fulfill his requirements for this major? Will he graduate on time? And we see that he did not. It says false. And we see this information that is sent back from the server, that these are all the courses that he did use, and we see that he's missing a course, 133. Isn't listed, and he's therefore not going to graduate. And we also have a class that is unused, 132, which happens when there are equivalent courses. So in this case, 132 is equivalent to 379, and therefore we don't need both of them. It's redundant, and therefore it's being unused when we're talking about validating a course. We also see that residency is fulfilled in this case because there are enough courses that satisfy the 267 code of psychology, so we don't have to change anything. So now let's fix all our things. We're going to delete 133 because we add 133 because we need it. We're going to delete 132 because it's redundant. We're going to delete 121 and replace it in the correct spot, which is in semester 2, the second semester. And now we're going to validate again, and we're going to see that indeed we fulfill all of our prereqs, we fulfill all the concentration requirements, and we are still fulfilling our residency. Once a student has a valid plan, he can go ahead and optimize it.
The student has to fix the semester of some courses, meaning that he requires that they be placed in the semester that he provided. Meanwhile, he has left the semester of some courses undefined. This is where the optimization program comes in and places these courses in the optimal location based on the optimization method that the student has chosen. However, we see that when the student tries to optimize this plan, he is unable to do so because he has fixed too many courses into semester number 0. This goes against business policy, which does not allow a student to plan more than 19 credits per semester. The student changes the semester of these courses to be undefined, allowing the program to place these courses in the optimal location. However, he decides to fix the semester of courses 123, 122, and 134, which he insists on taking in the 3rd and 4th semesters, respectively. As can be seen, this plan is not optimizable. This is because course 133 must be taken after course 123 but before course 122. With courses 123 and 122 placed in back-to-back semesters, this is not possible. The student has now decided to allow the optimizer to place all of his courses except for courses 122 and 134, which he insists on taking in semester number 4. The student decides to optimize this plan, and voila! It works! Note how more courses are placed in the earlier semesters because this is the quickest path to graduation optimization method. In fact, there are no courses in semesters numbers 6 and 7. The student decides that he would prefer a more balanced schedule, so he picks that method of optimization instead. And it's a success. Note that courses are placed more evenly throughout the semesters and that all semesters contain courses. Happy with this plan that the optimizer provided, the student decides to save this plan.